In this lesson, I'll show you how to solve applications involving distance, rate, and time. The question reads, Kevin flew his new Cessna O-2A airplane from Jonesburg to Mountainview, a distance of 2,560 miles. The average speed for the return trip was 64 miles per hour faster than the average outbound speed. If the total flying time for the trip was 18 hours, what was the plane's average speed on the outbound trip from Jonesburg to Mountainview? In order to be successful with this problem, you'll need to know the formula for speed. Speed is a comparison of distance to time. So I'll write that down. Speed is equal to distance per time. Now there are two trips, one where he goes and one where he comes back. And together that takes 18 hours. So if I rearrange this formula, where I solve for t, I end up with t is equal to d over s. The time it takes Kevin to reach his destination initially can be represented as 2560 over s, representing speed. And the time it takes him to return back, they say that the average speed for the return trip was 64 miles per hour faster. So again, 2,560 over s plus 64. So that's the time to get there, that's the time to return, and together this makes 18. The equation that we just generated, surprisingly, is a quadratic equation, even though at first glance you don't see s to the power of 2, which is an indicator that something is quadratic. We see s and it's at the bottom of these two fractions. Let me show you how we can solve this, and in the process you'll see that it becomes a quadratic equation. The first thing that I'll do is multiply this whole equation by a common denominator. The common denominator will be these two multiplied together. So s bracket s plus 64. If I multiply each of these three terms by s bracket s plus 64, this term becomes 2,560 times s plus 64. The reason being is, if we multiply this to that, this s and that s will cancel out, leaving you with s plus 64 times the numerator. If we multiply this now to this fraction, we end up with 2560 times s. This time s plus 64 cancels out. And multiplying this to 18, we get 18s bracket 6 plus 64. It still doesn't look like a quadratic, but it will once we expand. Remember, we're solving for s here. So if I expand this, I end up with 2560s plus, now let's see what 2560 times 64 is. That number, 163,840. Plus that term is equal to, and if we expand this, we actually end up with 18s squared. It shows to be a quadratic finally. Multiplying 18 to 64, we end up with 1,152. So plus 1152s. Don't forget that variable. Let's bring all the terms to one side and set one of the sides equal to 0 to solve. So if I bring that over, I get minus 18s squared. If I bring that over, it becomes negative, and combining it with this term and that term, 2560 plus 2560 minus 1152. Remember, it becomes negative when you move it over. We get 3,968. 3,968s plus our constant 163,840. We have a leading negative number. We can multiply everything by -1 to get rid of it. And if I do, I get 18s squared minus 3968s minus 163,840. At this point, you can use the quadratic formula to come up with the values of s, except I'll use a function on my calculator. Your calculator may or may not have this feature. If it doesn't, then you're bound to use the quadratic formula. So our a term is 18, our b term is negative 3968, and negative 163,840. One of our solutions will be 256. So let me write that down. 256. And our second solution happens to be negative, which we are going to discard because in this case, the speed being negative doesn't make sense. So I'll be discarding that and using 256. Remember, the question was asking what was the plane's average speed on the outbound trip, so when he first leaves the airport. In that case, we use 256 as our answer. So initially he was 256, and then when he returned, he was 64 miles per hour faster. Had they been asking his return speed, you would be adding 256 to 64, but in this case, we'll just leave it as 256. And there you have it. Another example where we set up and solve quadratic equations, and in this case being an application problem involving distance, rate, and time.